In this video, we're going to look at all the different strategies that we have for testing series. We've seen a bunch of them, and there's specific ways that we can look at them to be able to determine which one we're going to use, because sometimes there's better ones to use than other ones. So the first couple ones that we're going to look at quickly are the p-series and the geometric series. So the p-series, remember, is if it's 1 over n to the p power, it's going to be convergent if p is greater than 1 and divergent if p is less than or equal to 1. So if you see something that looks like a p-series, just do that real quick and you're done with it. You don't have to worry about any other tests. The next one is the geometric series. So if it looks like a geometric series and it's in the format of a times the ratio to a power of n, it's going to be a geometric series. We know this converges if the absolute value of r is less than 1, and diverges if the absolute value of the ratio is greater than or equal to 1. So we might be able to move some things around to make it look like a geometric series and figure out that ratio. If you can do that, it saves you a lot of time compared to doing some of the other tests. The next test is the comparison tests. If you have a series that looks like a p-series or a geometric series, but you just can't get it into those formats, maybe you can compare it to one of those series. If we can compare it to it, then we don't actually have to go through and do the other tests. We just compare it to it as long as the series is always less than the p-series. We know in the p-series converges, then we know it converges. If it's greater than and we know the other series diverges, then it diverges. So we can actually use that to do some of the testing as well. The next set of tests have a little bit more work that goes around with them. So the first one is if we can look at the series and say that limit I know is not going to equal 0, then you can just use the test for divergence. If the limit of an equation does not equal 0, we know automatically that it is going to diverge. The next one, alternating series test. The alternating series test is pretty obvious that where it works, it's got to have that -1 in the series. So if you have a -1, look at the alternating series test. The next two are ones that need a little more work and a little more calculation. We have the ratio test. The ratio test works really well if you have factorials or other products, including things that are raised to the nth power. But do remember that the p-series is always going to equal 1, and if the limit goes to 1, the ratio test does not work and can't be used. So that is one of those restrictions. The next one is the root test. The root test has the same restrictions as the ratio test. So if you have stuff with something raised to the nth power, the root test may be a useful thing. Remember, if the ratio test doesn't work, the root test won't work, so and vice versa. The final thing you want to do is look at the integral test. If you can do the integral of it, take the integral of it and you can use that to test it as well. But remember, the integral test does have some restrictions on how it has to use. It's got to be positive and it's got to be decreasing for it to be able to be used as a constant or continuous for the integral test to work. Okay, let's look at a few quick examples. This is the first one. We have the series of n-1 over 2n plus 1. And if you look at this is one of those ones that it's not a p-series, it's not a geometric series, so and there's not any of them that's going to work there, so doing a comparison test might be not useful. But if we look at this, if I just do a quick limit in my head, remember one of the tricks you learned in pre-calculus was if you have the exponent or the power of the top and the bottom of a fraction is the same, you can literally just look at the coefficients of it as you go to infinity. So I know this one is going to converge to 1/2. So the limit is 1/2. Since the limit doesn't equal 0, I know it diverges based on the test for divergence. The next one, we've got the series of the square root of n to the third plus 1 over 3n to the third plus 4n squared plus 2. This is one of those ones that it kind of looks like we might be able to do a limit to it. So I can use the limit comparison test to be able to test this. So it's a matter of figuring out what am I going to compare it to. So I can compare this one and limit all the lower terms, the things that would fall out as we get higher and higher. So I'm just going to look at the square root of n to the third over 3n to the third, which means I'm going to compare it to 1 over 3 n to the 3 halves. And that right there is a p-series. And we know that that p-series there converges because the p-value is greater than 1. So comparing it to this function, I can actually come up and say that that one is also convergent. This one, I've got a -1 in front of it. So right there, I'm going to use the alternating series test to do this. Remember the alternating series test, this looks at two things. The limit has to go to 0, and it has to be switching back and forth. So it will actually end up meeting both of those criteria in this case. The next one, this one's 2 to the k over k factorial. This one has a factorial in it. Whenever you kind of see a factorial, try the ratio test. That's a key piece to the ratio test, and one of the ones that works really well with that. So we would do the ratio test, and this would determine if it converges or not. And the last one, we have 1 over 2 plus 3 to the nth power. This has got that 3 to the nth power in it, and we're just adding something to it. So this really kind of looks like a geometric series. So we can compare this to the geometric series of 1 over 3 to the n and determine if this one also converges or not. So those are just some examples. The section of the book has a lot of other examples that you can try and work on with this. This is probably the best section to try and do, figure out if you actually understand it, because all the problems in it don't tell you which test to use. So you have to figure out the test and then do the convergence part for it.